And we move on to the last presentation today from Exfil around the visa portal, right? So it's only, oh no.
It's not downloaded, we get it from yeah.
Go ahead.
I can move with this. Speak with that. Yeah. Yes, hello. Yes, will be the last talk. Not very long. It's about software here from ILL and used at European Exfil. So lessons learned from conducting workshops and trainings with the software, with the visa platform. And what's this visa platform doing? It's for virtual infrastructure for scientific analysis for virtual machines. And this is quite handy because it abstracts away infrastructure from when you look at it from the user side, and it abstracts the specifics of the use cases the users bring when you look at it from the provider side, from the facility. So when you look at this dashboard, which comes from Read the Docs, you see 170 instances running. Those are virtual machines. Users are connected, doing their research. And on the right side, you see what those users are seeing is either a Jupyter ecosystem launching Jupyter notebooks or as Linux remote desktops. Users may choose and switch back and forth depending on their needs. And what I think hasn't been done here at the ILL or ESRF too much, please correct me if I'm overlooking something there, is actively inviting use cases to provide such virtual machines because the facility can now run virtual machine images provided by users, and users kind of agnostic to where this runs. So this comes here in the open source collaboration track, and Visa is a software by ILL that has been open sourced as a part of the Photon Neutron Open Science Cloud project. And yeah, what's happening when you open source a project, people adapt it and use it for completely something else. And I think that's what we're doing in parts. Here you see screenshots from ILL explaining how they see the software they developed and open sourced. So when you look at the left picture, it's depicting a scientist doing remote data analysis. So the flag should give you the idea the scientist sits in the United Kingdom but works on a virtual machine in the cloud here on this campus and can speak languages of the choice which are embedded in this virtual machine image that the guy launched. They are going a step further here, and we never did this, and we never took this into account at the European Exfil, using this even for remote experiment control. Right on the right side, you see now the same scientist having that switching something on and off, actually having that virtual machine connected to the Nomad and to a running experiment. So we were more or less looking on the left side of this, the remote data analysis, and European Exfil joined MOU, signed a memorandum of understanding together with other facilities to work in a visa collaboration on a sustainable collaboration on this open source project, with the idea to provide users with access to open data, software, compute infrastructure, and support. So that was the motivation in the Panos project when we started. How do our data look like? They can be quite diverse. I show you that slide basically for that message. It has been shown in other talks we have just seen. The use cases are quite diverse. So scientists look at this from different angles, different needs, different detectors, coming with diffraction data, spectroscopic data, mixed up with data from diagnostic devices, control data. And the thing is that comes at a very high repetition rate of 4.5 megahertz in our facility. And that means open data sets are large. Those detectors, the large area detectors, are capable of, if you average this, writing a petabyte of data in one day. So the consequence of that is that data must be analyzed and reduced at the facility. And those virtual machines more or less have to either run at the facility and access those large-scale data files, or the data has to be reduced so that it's even possible to work with this in such a system. So for the large-scale infrastructure, the high-performance cluster, our users get limited time. That's allocated for a given proposal for a given beam time. And that means users have to deal with site-specific authentication, authorization, networking, and so on. And that's the exact idea of Visa, to abstract that away. And here's one use case which we had. So I provided this Visa base image where I installed software environments and so on from my perspective. And then scientists who wrote this paper, Extra XVerse, a tool to streamline serial femtosecond crystallography workflows, they added stuff on top of that. That's, of course, all built in GitLab pipelines, like has been mentioned. So those virtual machine images are defined as code, and GitLab pipeline running HashiCorp Packer goes off and installs all the software and pushes a virtual machine image to the cloud. That's all that Visa needs to know. So that's abstracting away the use case from the provider perspective. The provider only gets an image on the cloud. And how was that used now? So in the paper, when you look at that paper, you will find a data availability statement. And that reads exactly like that. Data sets used for this tutorial are freely accessible through visa.xfil.eu, and for European XFIL users add a DUI pointing to our metadata. Which means users can spawn a virtual machine, can spawn a notebook, like you see here, and find this data reduction workflow explained in great detail. A reduced data sample was prepared for this because this does not run on the large-scale infrastructure where the petabyte of raw data runs. So now this little no-bug should remind me of speaking about lessons learned, how it's in the talk. So there are a lot of moving parts in such a system. And suddenly you think, okay, some days to go before an event or before a paper launch. I just bring this forward to the next Ubuntu version. It should be easy. What happens next is you find, okay, you have in your Kubernetes cluster a secret, it's mounted, you've forgot about it almost, it's for authenticating with the remote desktop. And Ubuntu has raised the bit limit for such keys. So the key is too small, Ubuntu considers this unsafe. Okay, easy, so you increase the key size. So what happens next? OpenStack, the cloud platform, complains, no, too big. I cannot store this as a metadata value. Okay, so you read, how do I work around this? Has someone else found this? And you have ideas like, do I downgrade the security in the virtual machine image? And so a lot of moving parts there. And then you look in the code, you suddenly work with C code provided by ILL for pluggable authentication mechanism that you install as a package in those machines. Make it ready to work with new keys, because you learn that ED 25519 keys have the security with a much lower bit rate, so they may fit with OpenStack. And then you learn, no, because the Visa API's Java version is not mature enough to deal with that, because it's stuck at Java 14 at this moment. And to work with the ED 25519 keys, you need Java 17. And suddenly you have dig deep enough into the code to learn, hey, there's a hidden configuration documented nowhere. That means, Visa, please ignore that key. I will ship it by hand. And so that is one of this no-bug stories I have embedded here, which, you learn a lot from, but some little bugs are hard to remove. Other people who are brave enough to use this system are sitting in this room and talking at this conference about the control software used at European XFL. Is an in-house developed open source system, SCADA system, supervisory control and data acquisition system, and the Caribou GUI is the main operator interface at EU XFL. And you see here those screenshots show you that we came along a series of events to build images, to bake Caribou into a self-contained standalone virtual machine image. Started with Ubuntu 18, then went forward to Ubuntu 22, and on this Friday here at this conference we will carry this forward to a next edition of this workshop. And here you see a picture of 20 colleagues, or more or less, from European XFL learning about doing GUI extensions with the Caribou software, with Qt widgets. And before I move on and explain this, another little bug appeared, which made this plan crash to use this in the summer school. What happened? 2 days before, I received an email that the DNS system at DESY, where we used the cloud, the OpenStack cloud, is going to a planned maintenance, which means our participants cannot launch virtual machines. They can, but the virtual machines won't get an IP address. So they won't reach that virtual machine because no DNS system entry there. So what do? We leave tested grounds, and we decide to launch 20. We have 2 workshops going, another on ML, so 2 times 20 virtual machines beforehand in the tutors account. Why not? Works. And then we test them, and our tutors, they launch in their browsers access to Visa, and suddenly that generates so much parallel polling at the back end, which we saw before, but before that didn't come in the same millisecond. But now we have parallel polls in the same millisecond, and we hit a limit for 16 parallel database connections, which I never saw because database connections are so short and they don't come in parallel in the same milliseconds, so they open and close, open and close. Now they come in the same millisecond and everything breaks. It's not so easy to figure out because at the same time we have upgraded to Ubuntu 22, moved the whole thing into a new Kubernetes cluster, and so on. So many moving parts, and time's short. So learning the hard way. And this is what this gives. So what you see here is this use case with the Caribou graphical user interface. You can use this to build hierarchical scenes with Qt widgets. And I like the extensive use of labels here to explain the elements in great details. And what I like about those is it runs completely independent of data. So I do not have to mount data with this. The beam, the experiment is simulated. So it's a standalone virtual machine image, which I can build and run on a public cloud and use it for testing Visa's capabilities to launch those virtual machines not only on an on-premise OpenStack, but on some public cloud. So that's research of mine. And to close, that is also like a new use case, which I am not aware of, that has been seen so much in the focus of Visa development here, talking to the developers, is to exchange the flow of information. So before that was a tutorial, so experts teaching or explaining users how interfaces work. That can be switched around to apply empirical methods in research software engineering. My PhD project I am currently doing at the European XFL is around data reduction. This is a formalization of data reduction recipe. That's preliminary work of Philip Schmidt here and others at European XFL presented this last year and this year. Early results. So you see that is a domain-specific language expressing as an extendable series of semantic expressions how data is reduced. And that then can be operationalized to actually rewrite large HDF5 files. And because the use cases are so plenty, and the Visa virtual machine remote desktop can be shared and used at the same time, it can be used to conduct use cases and user interviews to learn about the many steps here, like how do users interact with our data reduction tools, how are such manual patterns like frame selections actually achieved, and work together with users to maybe extend this DSL with user-supplied operations, which comes handy if you want to talk to an LLM, for instance, in the future about such things, then such a formal description comes in handy. So to conclude, I have talked about 3 use cases we have applied on the Visa platform. Open access to reference data and best practices, running data analysis on sampled reduced reference data, and environments for trainings, tutorials on the Caribou system, using the collaborative remote desktop sessions for real-time support from domain experts, and the other way around, also looking at future work, empirical research and research software engineering, using those collaborative remote desktop sessions for interviewing users and learning ourselves. Thank you very much.
Okay, we're a bit over time, but still, is there a question for Michael? Well, if not,
then for the wine and cheese.
Yes, wine and cheese is there, and you'll be around. Anni, do you want to say something about wine and cheese and poster session?
Yeah, it's very simple. There's wine and cheese, and even beer, and so there's salad as well. But no, it's already ready. You can go up there. But I would request that the poster presenters are in front of their poster for at least an hour. Okay? So if you're really hungry, get something and go to your poster. What? Yeah.